Okay. Yeah. So today we'll be having more detailed understanding about the Java 8 new features started with the Lambda implementations along with function interfaces. We'll try to see different variants of demonstration. So as you all knew that I don't take you through a tour of PDFs or PPTs because that's not what we needed. We need to gain more practical understanding. But I've customized and created some 100 slides. Okay, and it's almost I'm work in progress actually. So I'll be completing that probably next week. I'll be sharing the whole study content, the 100 slides, 100 plus slides will be there. That you can use it effectively whenever you go for an interview. Quickly have a refresh by looking at that 100 slides. So that covers everything that is essentially required to take up an interview. Okay, you can be a little bit well prepared. So that I'll be sharing that as well as a study content for you people, so that you can leverage that at the best when you are preparing for the interviews, right? Okay. Now, probably few people might be already working with Java 8 related concepts. You might be aware of few things, but few people might be very new or pretty new to the Java 8 new features. Whatever it is, let's start from the basics, the fundamentals, right? The scratch. We need to start from the scratch. So that's what which I'm going to do. We'll try to learn as much as possible within the stipulated time period, so that we are entitled to cover everything that's essentially required. There might be many more things that I might not be intended to cover beyond this scheduled period, but that's all something which is on the bigger ocean. Probably you will get to know and you will learn them as you go along with some real-time projects. Okay, but I'll try to give you the best out of the best what is possible from my side to cover everything, and we'll see multiple demonstrations, not just about one demo. We'll try to reiterate the same concept in different angles, so that we will be more used to it while we are working with Java 8. Okay. Um, so I'm ready with the tool. I'm using the Spring Tool Suite. It's the same IDE which we used in Spring Training. So let's quickly go ahead and create a Java project. If you have any challenges, please do let me know in terms of voice, or if the screen is not visible, please do let me know in that case. Yeah. Okay, so let's name something as Java 8 week 1 day 1. Okay. Now you can see that the one thing that you have to notice here is I'm using Java SE14, right? I guess this we have already seen, people who have already attended Spring Training. From that day onwards, I'm just using 14. So this is which currently most of the projects have started to adopt. But then why we need to go back to 8? Because 8 is having a major change, right? Either you go for a 9 or a 10, or it could be a 12 or 14, doesn't matter. But 8 is the major version that actually had a predominant change, which talks about the Lambda, the functional interfaces. So if time permits, I'll try to give you some inputs about the Java SE14 the next week, if in case the time permits. Or else we'll try to connect offline apart from this particular training period, and we'll try to have some understanding of Java 11 and 14. Okay, those are minor changes in terms of coding or in the API. It's very a minor change, but 8 is the major change. So any interview you go for, the first thing that they address is they ask questions from lambdas and function interfaces, streams, APIs, right? So we need to be a bit ready to take over those interviews as well. Okay, now let's quickly go ahead and create this project. So this is neither a web application nor an enterprise application. So it's just a standard application, a standalone application. So no need of any servers required, as we did in Spring MVC part, right? So we don't need any servers. I guess the whole screen is visible. So let's go ahead and create a specific package first. So week 1, day 1 demos. Sorry, just give it as a name. Okay. So before I take you to this, the one thing that I wanted to highlight here is, I guess 100% people who have joined are already aware of Java, right? That's a prerequisite. So this is something very important. And in this specifically, what I expect is the people should be having some knowledge on anonymous class. Okay, anonymous class. This is something very important. But don't worry, I'll try to take you with some examples of anonymous class that we can use it in real time so that we will get the better understanding of how we can easily understand the lambdas or the function interface usages comparing with anonymous class. Only when you have when you understand better about anonymous class, it's quite good to understand lambda expressions. Okay. So, so this is something very important. And to give a short briefing about anonymous class, it's a class which doesn't carry a name in it. That's why it is called as an anonymous class. And we usually use the anonymous class for the purpose of reducing your lines of code, right? And it's been bounded to a single instance. So if you want the logic to be written only for a specific instance, it's better to go for anonymous class. But if you want to use it in different instances, you want to use them in a reusability fashion, then anonymous class won't work, right? Probably that you might be aware. If not, anyways, the demo will help you to understand that. Don't worry. But just try to have this key term, right? The anonymous class. That's something very important. When we talk about Java 8 Lambda, we need to think about anonymous class, because the only way that you can differentiate and say why lambda is required is only when you understand that the basic of anonymous class. Okay, just a second. Two people are waiting. Okay. Yeah. So yeah, hi Karthik and Silva. Thanks for joining. Hope I'm audible for you both. Okay. So let's go ahead and create. Okay. Now to have a better understanding, I'll just start creating with some domain class. It's a pretty simple demonstration, not too complex. So I'll be taking you with the demo of a domain class with the domain class, not just with some hang around variables. We'll just create some domain class and then we'll try to relate them effectively. So the domain class would look like this. It's a plain old Java object. So I'm going to keep the name as Apple. Okay. Uh, so this particular class is going to have some instance variable. Hope the text is visible. Yeah. Um, so why I took this class Apple is because we are going to manipulate this domain object in Lambda. Okay, we are going to use this to set up the Lambda template or Lambda syntax. But before we get into the Lambda syntax, as I said, that we need to understand the anonymous implementations, right? So either way, this class would help us in understanding it. So this is just a plain old Java object. Great. Now what we are going to do is I'm just going to create an instance variable. So I'll be commenting it wherever required so that it's more readable and more understandable. Okay. So this is unlike the earlier training that we had. This is more of a standalone application, as I said. So it's more of core implementation. So we need to understand each and every step more in detail. Okay. So it's better to have the comments wherever applicable. So I'm just creating an instance variable. Let's create a private instance variable, which is of int the weight of the apple. Okay. And private string, and we have the color of the apple. Okay. These are the two important variables that we have in this domain class. And as you all knew that we are supposed to create a getters and setters, and we can have a constructors, so parameters constructors, and if needed, we can have a toString method as well. So out here, let's first go ahead and create them. So generate getters and setters. So we got the getters and setters. I want a no argumented constructor, and I want the argumented constructor because at places I might not use setter method. So let's go for creating the parameterized constructor as well. So generate constructor using fields and generate them. So we got the parameterized constructor, and we have no argumented constructor, and we have a getters and setters. So what else we could have is probably a toString method. Okay. If in case I'm going to directly print the object, then I want the object state to be printed like this. Okay. So we go for toString as well. Hope this is clear, right? I hope you all can understand this. Let me reduce the screen size. Yeah. So just a recall, a couple of instance variable, and we have parameterized constructor, and we have a toString method, and we have no argumented constructor. These are for our convenient purpose. We created these couple of constructors. Okay, it depends on the use case, or it depends on the scenario to which where I mean it depends on the scenario where we can use these constructors effectively, and we have the respective getters and setters for both the instance variables. That's all we have in the domain class. So from here, we'll jump quickly into another application class. So let's say Apple application. So here we are going to use those domain classes. Okay. Now, first thing is we need to understand, as I said, first thing is we need to understand the anonymous class, right? So how we can use anonymous class? What could be an example? Now you notice that we have this apple in apple object. Now what we can do with that apple object? First, we'll try to learn that. So inside this apple application, I'm just going to have the main method. So if in case you have some challenge in understanding, please stop me. You can unmute yourself and you can raise your question. Unfortunately, the chat box is not enabled. So I advise you to please unmute yourself and raise your question if in case you have. So string args of, I guess you might not have much of a question here because these are very basic and simple. Okay, not too complex. So yeah. Now, so public static void main, and inside this, let's go ahead and create a list. You know generics, right? So I'm using generics out here, only a collection of apple object inside this list. So list of apples, list of apples equals new array list. Okay, that seems to be good enough. So we are ready with the object of list of apples. Now what we have to do is we need to keep creating the object for Apple class. So I'm going to create Apple 1 equals new Apple. You all can recall now that we already have a constructor which takes a couple of parameters. We do have a no argumented constructor. If in case you want to set them explicitly, you can use apple1.set weight and set color. But right now I'm not going to use that because I want to reduce the lines of code. So let's go ahead and use the parameterized constructor here. Um, yeah, Himanshu. Yeah, hi Himanshu, welcome. Yeah, so I hope I'm audible, Himanshu.
Yes, yes, uh, yes, Sabri sir. Yeah, I can hear you. You can hear me?
Yeah, just a second. I guess I have. Yeah, I can hear you, Himanshu. Thanks. Yeah. Uh, so just now we started. Actually, I was just talking about the anonymous class in order to understand the Java 8 new features called Lambda. And we are going to work around with the anonymous class right now. Okay, so I just created an Apple class which carries a couple of instance variables, and we are using a getting and setting operations inside this domain class. So that's what we have. Okay, so I'm dropping in the values to that particular object, the weight of the object. Literally, we consider them in terms of grams, so 75 grams or 25 grams or whatever. And then we give the color for this apple. So like which I'm going to create a few more apples. 1, 2, 3, 4, 5, 6. Okay, so let's give a different weight. Okay, so we have right now 6 apple objects, and all these apple objects are straight away getting into the list bucket called list apples. I'm sorry, list of apples dot add of apple 1. So since I'm using the list, it'll maintain the order as we insert them. So just make it 2, 3, 4, 5, and 6. Okay, that's it. We are done, right? So to have a better understanding, let's just try to list this list of apples in order to see some demos. I'm sorry, see some output or to get some output. Hmm. Great. So you can see that the output is displayed here, right? The respective object. This is happening. It's because we are using toString method, right? It prints the particular fields of the particular object in this template: apple weight 75 and color green. Next one is apple weight 25 and color red. It goes on. So we confirm that this application works intact. I guess you don't have any questions right now. If in case, please do raise it. But this is very fundamental. I've just created an Apple class with some set of fields and getters and setters, a constructor. I'm using that object effectively here by feeding in some values to the particular object. And then I'm collecting all the Apple objects straight into the list of apples bucket. Okay, a list bucket. So that's all we have done. Hope you don't have any questions on this. If in case, please feel free to unmute yourself and raise your question at any time. I welcome your question. Okay, please stop me, not in a hurry. So I will go step by step on a slow pace. Okay, so what's the use cases? What is that we're going to do with this? We have done all the creation of these, right? So what is that next that we are going to do? I guess I don't need this for a while. So let's maximize this. So it's more visible, right? The whole class is visible right now for you people. Okay. So yeah, as I was talking about, what is the use case that we can think of in order to understand the anonymous class? Ideally, we can talk about comparing the objects, right? So Apple 1, Apple 2, Apple 3, we can compare them and then see how we can utilize the use case of comparisons in order to do a sorting. So that's what we usually do to understand the anonymous class. So there are many ways. I'll also show you another way that we can use thread. Runnable method is there, right? So there we will be using anonymous class. But till now, I'm not taking you to anything about Java 8. Okay, I'm just talking about basics of anonymous class, which we are having it for ages. So you would have studied this in Java 5 or 6 or 7. So in those earlier language version of Java language itself, you would have studied about the anonymous class. So in order to achieve that, I'm going to have an external class to be written here called class Apple comparison. Okay, Apple comparison, a class which would implement. Okay, this is not even an anonymous class. Okay, this is even before the state of anonymous class. Okay, we are learning it very I mean low level of understanding the implementation of anonymous class. So this state is before anonymous class. Okay, so that's why I'm deliberately creating a class called Apple comparison, which implements your comparator. You all knew there is an interface called comparator interface, and that takes a generic, so it does the comparison for Apple objects. Okay, so that's what we have in this class. So Apple comparison implements comparator, and comparator has an abstract method. Let's dwell into that and see. Okay, hope you can see this, right? We have an you can have a notification here. It's already been demarcated as functional interface, at functional interface. This is a comparator interface, and inside this there is an method. Okay, you have a method called compare. Okay, equals. So default methods are there. We'll discuss about default methods. We have static methods. A lot of things are there. Okay. So, but the main idea here is there is one method. There is one method which is called as compare. Okay, that's what you need to get noticeable about. So compare method is an abstract method in this interface. You all knew that, right? Interface carries abstract methods, and that's what which we are doing it right away in this interface called comparator. Where is the class? Yeah. Okay. So now let's jump in here. I'm implementing the comparator. So what is that we need to do here? We have to override, right?
Over the compare
Yeah,
method.
correct. We got to override the compare method. So let's do that right away. And you can see it's automatically picking up the couple of objects which needs for comparison as a type Apple. That's happening because we have already provided the generic for comparator as Apple. I'm saying, hey, you need to do the comparison only for the Apple type of objects. That's what the statement is. So, okay, we have this in place. That's great. Now, how do I want to do the comparison? Is that you want to do it with the weight, or is that you want to do it with the name of the apple? Okay, I'm sorry, the color of the apple. So you want to sort them in based on some color, green and red, so alphabetical order, whatever it is. So in which way you want to use this comparison? Let's try to do it in all the possible ways. So first thing is I want to compare them in terms of the color. Okay, so we already have this O1 and O2. Okay, for our understanding, let's keep it as A1, Apple 1 and Apple 2 comparison. So return A1 dot. So here actually, while we are using this object, okay, the comparisons A1. So A1 is typically the Apple object, right? So from the Apple object, you are supposed to compare the color. So A1 dot, the first thing is we are going for using the get color method. So that get color method try to fetches the color of the specific object. Dot, we can go for the compare to method, which is offered via the string class, right? Get color return is what? It's a string, right? String has a compare to in it, and this compare to will carry the comparison of another object called a2 dot get color. I'm sorry, yeah, get color. So this is what the comparison is. So what this compare to will do is it will compare the alphabetical uh, way of comparing the objects, and they will try to apply the comparison, return a value. So if you look at this compare to, the compare to's return type is nothing but an int, right? So it compares it and returns an int value for in order to make a better sorting purpose. So that is what we have in this Apple comparison. Uh, if in case we want to do a sorting, then we have to ensure that we use collections, right? So collections will be effectively used for sorting. So list of apples. So what I wanted to do now, I already have all the Apple objects, and that's been collected in a single bucket called list of apples. Now this list of apples, the bucket need to be sorted, right? So there is a method called sort method. There is a method called sort method coming from your list sort method. This sort method takes a parameter called comparator, right? So I'm instructing the sort method, hey sort, please sort it based on the comparator that's going to be provided in. So right now it's null, but literally we need to give the object of the comparator class. So what the object of the comparator class is going to be? Just now we created one class called Apple comparison, correct? This Apple comparison object is going to be used as an input for the sort, and the Apple comparison, which is carrying a compare method, will be activated for each and every object when it is iterating the list, and it will compare it according to the comparison logic that we have written internally, and it will automatically sort. So that's what ideally that's happening here. Anyways, I'm not the intention is not to teach you the comparator. You should be aware of it comparator, but still it's good to recall them again. But this is very much essential, okay? So to understand the lambdas, so that's why I'm going step by step. So what we have to do is either you instantiate your Apple comparison here, or you separately create an object and then you forward it. It's up to you, but I'll make it a little shorter. I'll keep it a little shorter. So this is passing in the comparator class for sorting. Okay, great. Now post sorting, I just wanted to see the output. Okay, how it's getting sorted, and pre sorting also we want to visualize that. What is the difference between pre sorting and post sorting? How it's reflecting? Let's see that. Okay, here you can see that. Hope it's visible. Uh, I'm unable to zoom them further. Hmm. So this is the output. Hope you can see this now, right? Can you see what is the difference between this? This is pre-sorting, and this is post-sorting. Okay, pre-sorting is like green, red, then it is taking red again, and then green, and then red, and then finally dark green. So it is maintaining the order, right, in which we have inserted the object into the list. It maintains the order of the insertion. Insertion order is kept intact in the list, and that's what the list is meant for. But post sorting, what you can see as a difference is it's taking dark green first and then gives the opportunity for the green, and then goes with green again, and then goes with red, and then goes with red, and finally ends with red. So you can see that the sorting works perfectly here because the alphabetical order of sorting is what is happening here, which starts with D and then goes with G and then ends with R. But there are multiple R's are there. That's further, if you want to sort it, you can still further do a complexity of logic to be written. But ideally, to understand that a sorting have happened and the sorting is happening here right now is based on the name. I'm sorry, they're based on the color. Okay, based on the color, the sorting is happening. Okay, now how do we use it if it's going to be an anonymous class? How we are going to refer them in terms of an anonymous class? That's what which we need to see. Hope this is understandable for everyone. If you have any questions, please let me know. Let me pause it if in case you want some breathing space to understand. Please do ensure you raise your question if in case you have any related to what we have discussed right now. A very simple format, right? A list, a sort, and a comparator. That's all. Uh, Nothing too complex. But now this is explicit class written for comparator, right? Explicitly, we have written a class called Apple Comparison, which implements the comparator of type Apple. But I want to convert this to an anonymous class. So how are we going to do that? As I said, if in case, okay, let's take it like this. Okay, you have right now Apple application. Okay, Apple application. Then you might be having some other class, let's say A applications, B applications, C applications. In everywhere, you need this to be used. This logic, this Apple comparison need to be used. So can we reuse them? I mean, can we invoke them just like that in any class that we create henceforth? Like how we created an Apple application, which is using this Apple comparison. The same way, any class that we create henceforth can use them, correct? That's the idea. But when we go for anonymous class, right? When we are going for anonymous class, uh, the idea behind that anonymous class usage is only to a specific class environment. You cannot use it in different classes. You're getting it? You cannot use them in different classes. You can use it for only one class type of object. You cannot use it for multiple class type of objects. If you have any requirement in such a way that the usage is going to be very much limited only to that specific class, then we go for anonymous class. Is that correct? You all agree with that, right? So what I tend to say is, if this Apple application is alone in need of an Apple comparison, then there is no need to have a separate class to be written for it. Rather, you can then just think of having an inner class, kind of an inner class, and the inner class is going to be more of a nameless. Okay, it's a nameless class, so that it is going to be called as an anonymous class. So what anonymous classes? Anonymous classes are the inner class, a class inside another class, right? And that anonymous term says that it's a nameless for that particular class. There's going to be no name. But how are we going to generate the anonymous class? With the help of this comparator interface, right? This is what is the key component for creating an anonymous class. Here the name is there. What is the name of the class? Apple comparison is the name of the class. But wherein in anonymous class, there's going to be no name at all. And so we call it as an anonymous class, and it's derived from an inner class concept. So you will have an inner class representation for anonymous class as well, but there is going to be no name for it. So we'll see how we can do that. Now I'm not going to use this class. So almost some 5 to 7 lines of code we have written. That's not required. entirely. Now we can go ahead and use the anonymous class representation by saying, um, let's say, I mean, um, comparator, comparator of Apple, Apple comparator. Okay, it's an interface. We all knew that we cannot create an instance for it, but that's fine. I'm just going ahead and creating it. The reason is I'm going to call this as anonymous class. So this is what the structure of an anonymous class, right? You all agree with this, right? You create an instance like template, instance like template. It's not instance by itself because we cannot create an instance for interface. Please make a note of it. It's an instance like template. Okay. But this is not an instance. Noticeably, you will see that there's an open and close curly braces comes up and we put a semicolon and we place a semicolon there. It's just a block of statements. Okay, a block of statements, and this block is an anonymous block. Anonymous block. No name for it. So we don't use any keyword like class and then giving a name for it, Apple comparisons, and then implements comparators, not there. But ideally it does the same job of what we did earlier. Okay, you need to compare this line of code equivalent to the line of code that we have written here. So a named class which implements a comparator, but here a nameless class implementing a comparator. So there is a need for us to override the method. What is the method that we need to override? It's an interface implementation. So the method that we need to override here is again compare, right? It all stays the same. The logic stays the same. So we need to override that method and you just apply the logic. Correct? Uh, just change the name of the variables. Now what you're seeing is local to the class, right? Local to the class, I've created one anonymous class. And that too, this anonymous class is created inside a main method, right? We can create anywhere we wanted anonymous class, not a constraint. There's no specific constraint. Any method, anywhere you think of quickly you want to create some logic for the implementations, then you can do that. So your interface has single method, the compare method, right? But my question is to you people, if in case you can answer for this, if this interface is carrying three abstract methods, will it be possible to create an anonymous class?
No, functional interface having only one abstract method, single abstract method.
No, no, no. Yeah, that's fine. For time being, you forget about the functional interfaces. Okay. What I'm asking is, I have an interface, okay, and the interface is a comparator, and the comparator is having some method, and there are three methods, and all the three methods are abstract methods, three abstract methods. Okay. Now the question is, can an anonymous class can be created if the interface carries three abstract methods? Will it be possible to create an anonymous class? Here there is only one method that we have overridden. But what if in case there are three abstract methods or four abstract methods or two or five or any number greater than one? What would be the scenario? Will are we
How would we implement?
please yeah, tell me please.
All method need to implement.
All methods need to be implemented. Okay, so means you're concluding that still we are able to still we will be able to create an anonymous class even though if there are three abstract methods are there, correct? Is that what your conclusion is? All methods need to be implemented. Anyone else? Do anyone want to throw some light on it? Hope you are understanding, right? Right now the comparator has only one abstract method. That's a known fact. But what my my analogy is, what if in case there are 3 abstract methods are there, or 4 abstract methods are there? So yeah, if it's a functional interface, it's single method. That we will come to. That story is still there. We have to come to that story. Uh, but one answer says that all 3 methods need to be implemented. So that means we can create anonymous class. Anyone want to give any other answers for this question? Just come with your own understanding, not a problem, right? A little bit of interaction. Any idea? Okay, fine. So let me conclude this. See, yeah. Anyone? Do anyone want to say? Okay. So this is an anonymous class. This is the structure of the anonymous class. Okay. When the structure of the anonymous class look like this, you have the class structure. Please make a note of it. This is more similar like a class structure. You have open and close curly braces. But if I have a 3 abstract methods, since it's more similar like what we wrote in the previous line of code, it's just a class which is implementing an interface, but there is no name for it. That's the only difference, right? But you have all the flexibility of overriding all the 3 methods down here. So right now it's 1. You can download 1 more. You can go for 1 more. So you can override as many number of abstract methods needed, depending on the number of methods that's available in the interface. So the conclusion is, please make a note of it. This is where the difference comes in. Okay. Anonymous class implements the interface, and overrides all the abstract methods, that is there inside the interface. Okay, it could be 2 or 3 or 1 or 4 or 5 or 6, doesn't matter. But all the abstract methods need to be overridden. That's the rule. The rule stays intact when it comes to a named class or an anonymous class, doesn't matter. Instead of saying named class, I can even call it as a concrete class. Okay, that's a concrete class. The above one what we have created is a concrete class. That concrete class and an anonymous class rules are same, that if an interface is implemented, then obviously you need to override all the abstract methods. That's the rule. Now, what is the difference that you can notice between this anonymous class and the concrete class that we have created before? What is the difference?
Here no name.
Okay, there is no name. Very good. No name. Very good. No name. Okay. There is a name. Any other difference?
Line will be reduced.
Okay, line reduction. Okay. Any other point?
And then simple readability.
Readability is high. Good. Okay. So compared to the other class, this seems to be readability. And fourth point, I guess I already told you, right? If you want to make it more reusable, it's better to go for concrete class rather than anonymous class, because this anonymous class template can be used only within this Apple application, correct? But you cannot use this outside this class, or I mean, you cannot extend them into other classes. So that still stays intact. So those are some difference. This is very close to the specific class only, right? Any other important difference can you notice? Can anyone figure out? Okay, all these are valid points. Yes, I do agree with that. Any other point?
Generics is used here.
Yeah, there also we are using generics, right? I guess you would have noticed that, right? In the class up, we still go for the generics. Yes, it still stays the same. Okay, I'll tell you. The main one more difference that you can notice is it's implements, right? If it's implements, what does it mean? Can I go for one more implementations here? Will it be applicable? Can I go one more interface to be implemented? Of course,
Yeah.
yes.
Yes.
The meaning of interface is what? Multiple interfaces can be implemented, correct? That's the rule in Java, right? Multiple interfaces can be implemented. But in anonymous class, can you do that? Can we go for multiple interface to be implemented in a single anonymous class template?
No.
No.
No, that is not possible. Why? Because the anonymous class is depending on the specific interface type. Correct. You create a template only with the help of this structure. So that's the reason that we are very much limited and restricted in using the anonymous class. We cannot just like that go ahead and keep using the anonymous class. Okay, you need to rethink is the scenario really required with creating an anonymous class? Okay, you need to think on that. And more interestingly, I'm not going to use this anywhere other than the usage of the Apple application. Then ideally, we can go for using this comparator logic within the specific class itself. Okay, but you can't think of having a runnable here. So how do you have a runnable here? Is there any possible to create a structure or a template having, okay, one more runnable? Let's have it like this. No, you cannot. You cannot have like this. This syntactically, the structure is wrong. All right. So that is something very important. In anonymous class, it's more bounded to a specific interface implementation. But whereas when you go for concrete class, you have a freedom to implement as many number of interfaces that you wanted, and you can override all the methods and keep it ready and make use of it whenever required. Reusability is also there. Okay. So it has its own need. Okay, when to go for a concrete class and when to go for an anonymous class. Right. So now what we need to do now next? What is the next step that we need to do? Just pick this class, I'm sorry, the object. And so in this, line, we have to remove the instantiation part of the concrete class, right? And instead what we need to do? How you're going to use this anonymous class inside the sort?
Apple comparator.
Yeah, just carry this variable out here. Okay, that's all. This will still do the same job. Okay, no difference. It's almost same. No difference at all, right? But the only advantage is, yes, of course, the line seems to be a little reduced and more readability is there and more convenient and very much closer to the specific class itself. And yeah, now let's see what's the output is going to be. Okay, so for our differentiation, let me add one more apple and let's state them as blue in color. Apple number 7. This might not be more real time, but I'm trying to simulate as much as possible. Okay, instead of just throwing some basic demo, I just wanted to make it because real time means I have to go for a real application development, and then only we can understand that. So yeah, now you can see the blue comes in. Okay, the blue comes in as in the sorted order: blue, dark green, green, and red. Right? That's what is happening. Is this topic clear? If this topic is clear, then we can move ahead. What the topic is all about anonymous class. Why we go for anonymous class? How to create an anonymous class? An example for anonymous class use case is comparator, a well-defined comparator. We can also take an example of runnable. Quickly, I can even show a demo for that. So anonymous classes are like this. If you have any questions on this, please let me know. How to do a sorting, reverse sorting, this and that. That is not the area of concern here. Okay, so that is out of the scope of this discussion. Reverse order. Okay, alphabetically reverse order is all we can make it possible. That's fine. Absolutely, that's fine. We can still make that possible. That's not an issue. Any question? Okay. Now let's see the same thing in the other way around. Okay. It's going to be orange. Typically, apples don't be in orange color. It's all our imagination, and let's add one more apple out here. And this time I'm going to make a little bit of changes in this compare. Okay, so right now I'm just going to comment out just go for overriding it again. This time what I'm trying to think of is not just go with the color, instead you go with the weight. Okay, the weight of the apple. So the logic is going to be slightly different. So the compare, we have A1 and A2. The first thing is you have to put an if condition and say A1 dot get weight, which is if it is equal. Okay, if both the objects weight is same. That's the reason if you would have noticed I've recently created one more apple of orange which is having the same weight. Okay, so A1 dot get weight, if it equals, then you're going to return a numerical value called 0. Okay, it typically means it's same, right? So no much of a difference. So it's 0 difference. We have, okay, it's all a one-liner statement. So let's try to remove this. Let's go for else if. I have one more condition. What if in case A1 dot get weight is greater than A2 dot get weight? Then you got to return 1, right? Else you return -1. Can you understand this logic? Is the logic understandable? If it is same, return 0. If it is greater than, if A1's weight, apple 1 weight is greater than apple 2, you return 1. If neither the condition satisfies, then you better return -1. That's the logic. This is for numerical comparisons. Before it was on string, right? Alphabetical comparisons, but now it's very specific to numerical. So this you can interpret it in terms of a person's age. You want to compare the person's age. Now I'm just comparing the apple's weight. That's all. So we can go for using this sort again. Let me comment this and let's activate this, right? So this time the sorting is slightly different. Okay. So now what we do is we just run them. Now if you see the color, I hope it's readable. Okay. Now see the difference. It's not sorted on the name, the color of the apple. It's red, it's blue, it's orange, it's dark green, and it goes with green and then goes with red. So obviously it's not sorted that way, right? But after sorting, if you see, it's like 15, 25, 34, 34. Please make a note of it. It's 34 and 34. Within 34 and 34, if you notice, it's like color blue and then color orange have been taken, and then we go for 64, and then we go for 75, and then we go for 100, and then we go for 120. You're getting it, right? So now the sorting is happening on top of the weight of an apple. Okay. Now what we need to do for relying on this particular logic? in an anonymous class. Just move this snippet of code, right? So just copy them and drop it here. That's what we have to do. Cool. So again, for our understanding, let's go for one more 34 with let's say alpha, something like this. Okay. Or let me insert this somewhere in the middle. Apple number 9. Okay. And apple number 9. Okay. Done. Now I'm using this comparator. Let's rerun them. And this time, if you notice, again the same 15, 25, 34 alpha, 34 blue, and then orange, okay, and then dark green, and then it goes on. So within this 34, you can see there is a default sorting is happening: alpha, blue, and orange, right? A, B, and O. That's in place. It has happened here. But what if in case I'm just shifting it down? Okay, this apple line is going down. That's literally, I'm dropping it here and remove this or alpha and drop it next to orange. Will it make any difference? So insertion order is like that. If you notice, apple, weight, color blue, orange, and then goes with alpha. So initially it was seems to be unsorted. A default sorting is taken place, but that's not the actual output, right? It's taking B, O, and A. So internally there is no further sorting happens, okay, other than the numerical sorting. So it's seen in the order. So it seems to be a blue, orange, and alpha. Blue, orange, and alpha when it is same, because we have written 0. No changes. No changes. It's all intact, the same. A1 and A2 is same. You keep it in the same place. A1 and A2, again the next one, A1 and A2 comparison happens, you keep it in the same sort. I'm sorry, same place. So no difference. Okay. So further sorting internally, it doesn't happen. Uh, so the understanding here is either way, whether you do a sorting on top of color or you do it on the numerical sorting, you can still go ahead and create an anonymous class and write the logic like this. It's still feasible. Okay, highly feasible. Great. Now, what is the intention of this course? Is the course is to talk about only the anonymous class? No, that's not my intention. The reason I spent more time on anonymous class briefing is because we need to be very strong on that. I'll also try to give you one more demo. Please be patient enough. Probably you might be very good in that, but there are few people who might be new. So that's the reason I'm just going to give a runnable application. One more type of anonymous class. Okay. This also you would have seen many times. So I'm just creating a class called music, which implements runnable. Okay, runnable is an interface, and you got to override the run method and then say set max 3 boys. Right. Okay, so this is not an anonymous class anyway. What you have to do is you need to create a thread class T1 equals new thread off, and then drop in your new music off, right? And then go for T1 dot start. So this is not a method, I'm sorry. Public static void main string args. Good. Let's do a formatting and go down and say T1 dot start. Okay, that's it. A quick demo. I'm not going to explain them all. Ah,
So
that's a problem. Yeah,
spelling mistake in main.
correct. Uh, Sometimes we don't notice that. Okay, so you can see Backstreet Boys playing. So it's literally a thread. We have created a threaded object, music, which implements runnable, and then on top of the start call, the run method gets executed internally. Great. Now, can we convert this to an anonymous class? Shall we? Of course, yes. If you go to the runnable is another example for the abstract method. So you can notice that a runnable interface which carries an abstract method called run, right? And there's only one abstract method is there. Pretty good. Now, we have to get into the main method, and inside this, let's say runnable or equals new runnable of. Okay, so automatically you can see the template got created. The only thing is shift this code. Down here. And this time, let's say Westlife. Okay. Good. Now, instead of new music, what we are going to do is we are going to pass on. What we are going to pass on? We are going to pass on the R. Correct? Okay. Let's run that. So Westlife playing. It does the same job. Now this is a style of anonymous class. Correct? This is a style of anonymous class. Sorry. Clear? Any question on this? Anyone? I'll just pause here if in case you want to have some understanding of this. Pretty simple, straightforward, right? As a runnable abstract method. Even if it's going to carry 3 abstract methods, we don't mind about it because we go ahead and override them as a rule of an interfaces. So if there are 3 abstract methods, you got to override all the 3. If it is 4, you override all the 4. If it's 1, you override them with 1. If it's no abstract methods, then I guess we don't deal with anonymous class at that time because it's in marker interfaces, right? It will be called as, and if an interface which doesn't carry any abstract method, it is called as in marker interfaces. The marker interfaces are not entitled for anonymous class implementations. Any question? Hope you all are awake.
Yes, sir.
Okay. Okay, see, the reason for this live session is actually to have more interactions. Okay, so anyways, if there is no question, then obviously there's no much of an interaction. If things are clear, it's fine. But if things are not clear, please put up your question. Then there's no point in having a live sessions. Okay, right? I can just record it and share it with you. So utilize it at the best. Live is always live. So, and it should be live. Okay. Okay, so I guess I've made the best of to make you people understand the different variations of using an anonymous class. Now there's a right time. It's a right time to shift to the uh, functional interfaces in Lambda. Since we got an idea of this anonymous class, now we can jump into Lambdas. Okay, so I'm going to create another class called Apple application with Lambda. Okay, a bit of copy paste I will do it because we have almost all the logics we have understood. So few copy paste I will do, but before that, let's understand this, the fundamental. Lambda right? Is this lambda? How many of them are aware of this term called lambda? Uh, or I can put it this way. Have you heard about lambda calculus? Actually, I have a specific video on Java 8 I started with, but I was unable to complete that. It is there available on my YouTube channel. You can just go and have a look at it. I've spent enormous time to design it and then make things more clear. In order to actually start with Java 8, we need to start from this lambda calculus. Okay, but I'm not going to teach you that here. Don't worry, I'm not going to teach you the lambda calculus. If in case you want to catch that up, you just step into my YouTube channel and then you can have a look at it. So lambda calculus is the actual theme behind Java's lambda syntax. Okay. I'll just keep it short, but in YouTube it's a little expanded detailing will be there with more animated slides. Okay, so you can just have a look at it. But I'll just keep it neat and short right now. So in lambda calculus, what actually happens is it's a mathematical concept, right? Lambda calculus means obviously it's a part of mathematics. So we have x and we have y. Okay, x plus y, right? So when I'm saying x plus y equals z, okay, something. So when I'm saying x is 10 and y is 20 and the value is going to be 30, correct? So the expansion goes like this. So let's say z equals x plus y, right? And internally x equals 10 is given, y equals 20 is given. Now z equals 10 plus y, 10 plus 20. Okay, uh, but this is not what the calculus is. Calculus is pretty a bigger ocean of concept. I'm just trying to give you some sort of basic understanding. Now z value is what? What is the output of z? Or what is the output of z?
30.
Great. But I'm saying 32. Will you accept?
No.
No.
You won't. Okay. Uh, okay. So now will you accept that z is 32?
Yes.
Good. Why?
Because we
Why
are
your x?
adjusting that value, xy value.
No, that's what. So why you are accepting now it is 32. Before it was 30, I said 32, you didn't accept, but now you are accepting. What has happened? What has happened now?
Variable. Variable.
A variable y is modified, correct?
Yes.
But literally speaking in calculus, y should be acted as what? Constant, right? X and y variable should be constant. It has to be constant. It cannot be changed. Y should not be changed like this. You don't have the liberty to change. What goes in should come out. If you give it as 10, it should be 10 for y. If you give it as 20 for y, it is 20 only. In between that, you cannot change. You cannot change that to 10 plus 2, so y becomes, or let's say, after this, again I'm saying y plus 2. Y is initially 20. What is the value of y now? After this line is executed, it becomes
22.
22. But this is not acceptable in calculus because the variables of the calculus are constant. What goes in should come out. You cannot change intermittently, right? So the same rule is applicable in Lambda Java 8. So where the scope of Lambda is there, the local variables like x and y in the Lambda scope, not inside the Lambda I'm talking about, the surrounded environment of the Lambda local scope will be always, should be always constant. It has to be constant. You understanding? So Lambda calculus concept is derived in Java 8 lambdas and they still maintain that rule. And Lambda calculus is actually contributing what? Functional logic. Lambda calculus means it's functional logic, right? What do you do there? F of x. correct? F of x equals, let's say, x plus y plus z this time. F of x is what? F of x is a function, correct? And that's why we call it as a functional interface. The reason for functional interface term is because of the behind the background, it is actually derived from calculus. I'm not sure if how many of them have come across this history, but this is the fact. The need for Java 8 Lambda is actually to accomplish the functionality implementation rather than the class. Everything is function. Everything is function here. Actually, to be more precise, it's like f of x equals f of y plus f of z. Everything is seen as what now? Everything is seen as function. So in Lambda calculus, what they say is function, okay, your function is the first class, what? First class citizen. Functions are the first class citizen in calculus, Lambda calculus. The same is applicable for Java 8 Lambda. Java 8 Lambda, what they say is Lambda means it's a function, Lambda function. The Lambda functions are representing the first class citizen, not the object. But generally in Java, we keep first class citizen as whom? Classes and object, right? You all agree with that? It's a OOPS based principle. So Java means classes and objects are the first class citizen. But in Java 8 Lambda, function is the first class citizen, not the object. And that's why we call it as a function, Lambda function. And there where we bring the thought process of using an interface to achieve this Lambda and call it as a functional interface. But actually it is all coming from Lambda. I'm sorry, Lambda calculus. Okay. Yeah. Yeah. Any questions on this? Too much of history, but that's okay. Do anyone have any questions on this? So ideally, what I want to convey there is functions are the first class citizens. Number one. Number two, the fields are constant, not inside the Lambda. I'm talking about the field that is coming outside, from outside, because f of x value comes from outside. Okay, plus f of y, the value comes from outside. Okay, the outside environment value should stay constant when you are inside the function of the Lambda. That is what it means. You're getting it? Okay, fine. So Lambda, what is the advantage of Lambda in Java 8? Okay, Lambda calculus, okay, these are all history and story, I can understand that. What is the need for Lambda? What is the need for Lambda expression? What are we trying to achieve? What are we trying to achieve is, yes, of course, the function stays as a first class citizen. Function becomes a first class citizen in Java, which is an OOPS based concept. Now function stays as a first class citizen. Number one. Number two, we are replacing the what? The dash class. Can you fill it? We are replacing the dash class. What it is?
Anonymous class.
Very good. Excellent. We are replacing the anonymous class. That's all. You have learned Lambda now. So because the Lambda representation is all going to be more similar to anonymous class. Okay. Lambda expressions are replacing the anonymous class. Now we got to understand that the anonymous class, concrete class, was having how many lines of code? Let's say 10. Anonymous class was having how many lines of code? Let's say 7. Now the Lambda is going to have how many lines of code? Somewhere 3. So ultimately we are trying to reduce the lines of code. That's one thing. More interestingly, we are also trying to replace the anonymous class concept in terms of a function. And so we can also call this Lambda expressions as an anonymous what? Anonymous
Function.
dash.
Functional interface.
No. Yeah. Anonymous function. Instead of anonymous class, we are going to call it as anonymous function. So Lambda expressions are helping us to lead the way to create an anonymous function. Got it? Yeah. So technically, we have to understand how these Lambda expressions are going to appear. That is what we are going to compare right now. If you, in case you have any further mind blocks in understanding this, please let me know so that I'll try to explain at my best. And then we will move forward.
Sir, you told that the functions are coming from outside. So outside in the sense
Functions are not coming from outside. I said the function's input is coming from outside.
yeah, sorry. Function inputs in the sense it is coming from other class, right? Is my understanding correct?
It can be from other class, or it can be from other method,
Okay.
or it can be from other block. Okay, doesn't matter. Outside means it's not necessary outside the class. It can be outside the class. It can be within the class, outside the method. Okay, within the method, outside the block, if block, anything. But it's outside the Lambda environment. It is what it means. Anyways, when I'm showing the demo, you'll understand.
Yeah.
But yeah, of course, one way is, yes, you can think of even coming from outside the class. Your another class is giving a call to the function, passing the value to it, then it's an outside parameter, right? A parameter is from outside. Yes, of course. A function to function call is also an external parameters.
Yeah.
Any other question?
Actually, through function, what we are achieving, sir, actually, normally, normal class also same only doing, function also same only doing. But why we are saying it is a function like that?
I mean, you mean to say anonymous class versus Lambda function?
No, actually, same work only this Lambda function also doing with reduced code. That's it, the difference I am accepting, that thing I am getting. 3 lines of code it is reducing, but it is function like that we are mentioning. No, that concept why we are here implemented like that, some clarification needed, sir.
No. See, you mean to say that the function which is the value is not changed, x value is not changed, y value is not changed. Is that what you want to
Yes.
understand?
For
Yeah,
example,
that's what.
we are a
Yes,
class.
yes.
We are first initially we are implementing using a class. After that, we are using interface. We are reducing the code through Lambda expression. We further reducing the code. That is the chain process. Like that, I am understanding. After that, we are externally we are saying here function as a functional interface like that. So how it is enhanced the program using the functional interface like that, sir.
Yeah, see, that's what I would like to explain is the functional interface. Forget about the functional interface. We are not talking about the functional interface as such. We are only talking about the Lambda function now. Okay, Lambda function is what is the theme. So here I'm highlighting it's a function, right? So Lambda means it should be function, and it is derived from where? As I said, it's Lambda calculus, because there everything is function, only function. There are certain language, right? I'm not sure if you would have seen. There are Pascal. Have you heard about Pascal? It's like Pascal, or I'm sorry, not Pascal. Haskell something. I could not recall that. Those are some examples for functional programming language. We have something called functional programming language, right? The functional programming language deals with whom as a first class citizen? Function. Literally saying like C, even in C we have only deal with functions. It's C++, we deal with objects. So Java is trying to bring more similarity to that functional programming using this Lambda function, because it deals only with the function. But the rule for that functional Lambda function is followed from the Lambda calculus. That is making the value to be constant, not only from Lambda calculus, not only from the Lambda function, even in the anonymous class, it stays the same. Okay, I'll first let you explain this so that you'll understand. See, the main theme of functional interface, I'm sorry, the Lambda function is not just about reducing the code alone. Okay, it has many other advantages. As we go along, you will understand that. Now, you just look at this. Okay, you can see this, right?
Java itself is advanced compared to the C. Then why we need to implement C like functional concept in Java like that? I am getting confused. That's it.
No. We cannot consider in that way. See, using a function here also we have functions. Okay, we call it as what? We have something called main. Main is what? It's a method. Here we call it as a method. There we are calling it as what? Function. But the thing is, everything is surrounded within the class. That's the only difference in Java and C. C is having everything hanged around as a function, but here you are surrounding all the functions within a class and you call it as a method. We still follow the C's principle, right? C and C++ principle is always there in Java. We cannot avoid that. But the functional programming usage is what we need to see. The functional programming usage they brought is majorly to ensure that your style of writing an anonymous class can be replaced into a functional implementations or lambda implementations. But the next understanding is this lambda expression syntax can be extended to the next level. What is the next level is what you call it as a streams. We have streams API in Java 8, correct? You would have probably, if you would have seen that or you would have worked it, you would have noticed that the API itself is designed in such a way to leverage the features of lambda functions. Do you all agree with that? We have something called Streams API. If you're not aware, it's okay. We are going to learn about that more in detail. That Streams API is completely designed. It's a new API, right? Streams API is a new API. It's a difference now. Nowadays, it's going to be collection versus streams. Before in Java, we will study only collections. Now we need to study streams also, mandate. And we need to know the difference between a collection and a streams. So Streams API is built in keeping in mind this lambda functions. So you're going to thoroughly use lambda functions inside the streams. So usage of lambda functions are seen in many ways. So don't just think from the perspective of it's not a pure functional programming. It's not achieving the pure functional programming. Still we have class, still we have object, but they are trying to imitate it. Okay, they are trying to imitate it to support in these areas of APIs, like in Streams API, we can able to make use of that. And modification of that is protected. Let's go for JavaScript, or let's take an example of TypeScript. In Angular, we use TypeScript, right? So there also you have this anonymous method, right? Have anyone seen that? Anonymous method in
Yes, TypeScript.
yeah, so in TypeScript, you have anonymous method. What is the purpose of the anonymous method there? It is actually a callback methods, right? It is all called as callback methods. And those callback methods will generally have no name, correct? Callback methods are having no name in it. Okay, nameless methods. And those methods are actually, you'll be using a equal to with this symbol, greater than symbol, representing a denotation of the anonymous method. Okay, but there it is not like lambda. We don't call it as lambda. Even JavaScript has that. Even the TypeScript has that, right? So callback methods are no name in it, and so it is called as an anonymous. The functionalities are more. The same way here also, the functionalities are more. The reason for bringing it is majorly to support the streams effectively. Java 8 main focus was to support streams and also to ensure the backward compatibility is resolved majorly. We'll discuss that one by one. Yeah, I was about to explain this. I'm sorry, I'm taking a little bit of time there. If you see this, let's say int x equals 10, okay, and so somewhere inside this x equals 90. Okay, now you have to notice that when I'm saying x equals 90, you get some error message. Okay, what is this error messages? Please read out this. You can notice that externally yeah. So why there's an error? Can anyone tell me? It's already there. The error is there. The error message is there. That's fine. There is a variable, okay, which I've declared. It's an x, correct? And it is initialized already. This is an anonymous class. Do you agree? Yes, of course it is an anonymous class. But the thing is, when the same variable, when I'm accessing here, I'm not able to change. So what does it mean? It means it's effectively final. Effectively final. effectively final. So by default, this is final. Default, it is final, effectively final. These are final variables. So anonymous class is also representing the lambda calculus. The rule is followed in anonymous class itself, which is still extended in the anonymous function, that is your lambda function. Effectively final. We have a topic to be discussed on that. Effectively final. That is called as lambda capturing. Okay, technically they call it as a lambda capturing. We'll come to this point. Anyways, it's too early that I have explained. You can still recall this. So the error is there. You have to resolve this error. How do you resolve this error? You better don't reassign them. You have to use it as it is. So f of x, which is coming to lambda function, it should be used as f of x of the 10 only. You cannot change it later. You should not. Now, I'm right clicking this project, go to properties, okay, look at the compiler, and in the compiler level, I'm downgrading it to 1.7. Please make a note of it. The compiler version is downgraded to 1.7. If I make it to 1.7, okay, if I make it to 1.7, if I'm using this x, okay, that means it is like what to say? It is. Okay, let me just go for this. Yeah. So if I hover the cursor here, you can notice that cannot refer to the non-final local variable x. Now the error is different. Please make a note of it.
Explicitly mention final.
Yeah, because before it was effectively final. Now it is saying, hey, listen, yeah, non-final local variable x, non-final local variable x defined in an enclosing scope. So means it's developer's responsibility to mark them as final explicitly. Okay, if so that it denotes that you cannot change it. Correct? Error is different entirely. It's a non-final variable and you cannot change it. So literally, if coming from an external variable, you are not supposed to change them. So it has to be demarcated as final. Okay, so that it's deliberate. It's deliberate and it's very clear that it's a final variable and it should not be changed. You cannot change it. I'm not sure how many of them are aware of this concept. In anonymous class, the external variable, if you are trying to modify, then it is treated to be a final variable. So you don't have the opportunity to modify them. You have to use it as it is. The same principle is followed in lambdas also. Okay. Okay, you just keep this information for a while. We'll go there and then we'll see that. I'll just bring it back. The reason I changed it is because the errors are different. This error is effectively final. This is introduced from Java 8, but this error comes from Java 7. Okay, see the difference between the Java 7 error and Java 8 error. There's a big difference. Okay, let us upgrade to 14. Just the default. Okay. Okay, forget about this. People who are not able to follow up that's okay. Absolutely okay, not a problem. We'll see this in short. So I was about to convert this, right? Apple application with Lambda. I'll take another 5 more minutes and then we'll go for a 10 minutes of break. Okay, what is it we need to do? Public static void main string args. Okay. So what we are going to do is just copy the logic from the Apple application. So what is the logic? This is the logic, right? So all these should come up there. So I'm copy pasting it. Let's have this aside. Now, as per the Java 8 standard, okay, Lambda expression can be achieved. Lambda expression, Lambda syntax, I can call it as Lambda syntax, Lambda expression, Lambda function, okay, Lambda snippet, Lambda code, whatever you want to name them, you name it, but prefix it with Lambda, okay? A Lambda expression or Lambda syntax or Lambda function or Lambda snippet or Lambda code, everything means the same. Now, if I want to achieve this, if you want to achieve Lambda expression, or if you want to achieve Lambda syntax, that's applicable only when you have a functional interface. So the understanding is, what is Lambda syntax? That's a question, right? What is Lambda syntax, or what is Lambda expression? What is Lambda expression? Can anyone explain how you can define to this? What is Lambda expression? How do you define this? What is Lambda expression? Any idea? Anyone? People who can think of.
It deals with functions.
Okay, it deals with functions. Okay. Okay, I'll give it. Anyways, we are running out of time, right? So I'll give the answer here. See, what is Lambda expression is? Lambda expressions are the implementation of whom? The functional interface. Okay. Functional interface. The functional interface, functional interface implementation, functional interface abstract method implementation is what is your Lambda expression is. What is Lambda expression? Lambda expressions are the implementations of functional interfaces abstract method. Do you all agree? Okay, now the next question is, I don't know what is functional interface. Then only I can say whether it is correct or not. So in order to learn, first we have to start from functional interface. We have to start from functional interface, correct? Now what is functional interface? Functional interface are nothing but a normal interface. It is an interface. You know what interfaces are, right? A normal interface. So what I'm going to do shortly to make you people understand there is, I'm going to create an interface. Interface called summary. Okay, public void coach. Is this an interface or not? Of course, it is an interface. What a stupidity of question, because it is already an interface. Yes, of course, it's an interface. The name of the interface is summary. Okay. Now, what is this? This is your
methods inside the interface.
Yeah. What method it is? It is an abstract method. Correct? Interface carries an abstract method. How many abstract methods are there?
One.
So we call it as single method, single abstract method. Okay. In the recent days, when I was even today, inclusively today, I was in the interview panel. Okay, almost 2.5 hours. I had an interview. So in the morning, I usually ask people, can you? They used to say, I'm aware of Java 8. I worked on Java 8. Okay. In order to testify them, I simply ask them, can you just explain what SAM interface is? Can you tell me what SAM interface is? Have you ever heard about this SAM interface? Anyone?
It seems to be single abstract method interface.
Yeah, correct. So SAM interfaces are nothing but functional interface. Why we call it as a SAM interface is that interface will carry only what? single abstract method. It should carry only single abstract method. So functional interface rule is nothing but single abstract method. So I'm calling it as a SAM interface, and it's a generic call that usually all developers, Java 8 developers used to call them. They won't call it as function interface. They call it as a SAM interface. So in Java 8, SAM interface means it is an functional interface where the functional interface represents the rule as SAM, which is nothing but single abstract method. So usually interfaces can carry n number of abstract methods, correct? Do you all agree with that? N number of abstract method. But in functional interface, the rule is it should carry only single abstract method, SAM, single abstract method. Don't forget. Okay. If like Sabri like person, if you face in an interview, that person will ask this kind of a stupid question. What is SAM interface? So SAM interfaces are nothing but single abstract method interface, which denotes to the same as functional interface. It's all the jargon that we use. How we call it, it's depending on the person who's asking you the question. So I use this jargon called SAM interface, which is nothing but a functional interface. Why it is SAM interface? Because that interface should carry only a single abstract method. And that's what the functional interface is all about. So here right now, how many abstract methods are there is only one. So can summary be a SAM interface?
Yes.
Correct. Yes. Or to be more precise, can summary be a functional interface? Yes. Yes, of course, yes. Summary can be a functional interface because it is carrying only a single abstract method. That's great. Now the next thing, what I'm going to do here is I'm going to say okay. Now there are two abstract methods. Okay. Now there are two abstract methods. Now there are two abstract methods. Can summary be a SAM interface or a functional interface?
No.
Can it be called as? No. What the functional interface says, it should carry only
One abstract method.
one abstract method. Correct. But I have two in it. So obviously summary is not to be called as a functional interface, neither functional interface nor a SAM, because both refers the same. So you cannot call them as a functional interface. So the rule for functional interfaces, you should carry only single abstract method. But can this interface carry a two abstract method? Forget about the SAM interface, forget about the functional interface. Can an interface carry two abstract methods?
Yes.
Yes.
So this is only a normal interface, correct?
Yeah.
So that's the reason what they have done is to differentiate it, but still it is acceptable. There is no compile time error, right? Either I have a one or either I have one or two, doesn't matter. Still it is acceptable by the compiler. But when I demarcate this with an external annotation called functional interface, okay, then there is an error pops up. Why the error pops up? Because explicitly it is a denotion to the compiler stating that this interface have to be marked as what? Functional interface. In that case, what the compiler will say, hey, developer or programmer, please ensure that this is marked as a functional interface. As per the rule of a functional interface annotation, you are not supposed to have more than one abstract method. You are entitled to have only one abstract method inside the interface. So whether you give at functional interface annotation or not, still the interface can be a functional interface if it carries what? Single abstract method. Correct?
Yes.
So this is a kind of a question that I ask to the people. Even in today I asked this question. What you will do if an interface is not marked as a functional interface? I just put the question like this. If you want to create a functional interface, is that mandate to have a functional annotation? Is the question that I used to ask. Hardly some 50% of the people will say yes. I mean, not required, it's optional. But 50% of the people used to say yes, it is mandate to have a functional interface to create a functional interface in Java 8. But that's not the case. You don't need an annotation called functional interface to refer it as a functional interface. The only reference that's required for understanding it as a functional interface is the rule of SAM. Is the SAM introduced in Java 8 or Java 7? Any idea? It is introduced in Java 8 or Java 7?
Java 8, sir.
Java 8. No. It is introduced in ages before. Even in Java 5, Java 4 we had. You have Runnable, right? Runnable is an interface. For ages, how many methods is there in the Runnable interface? Forget about Java 8. Java 7, Java phase is put in Java. That is the only difference. You're getting it? Yeah. So as per the rule, now the thing to understand Lambda, first we need to start with functional interface. So I have created one interface. Now see the error is resolved because it is deliberately marked as functional interface. But if I remove this functional interface, still is this a functional interface? Is what my question is. Still, do we call this as a functional interface?
Yes.
Yes. As long as the interface is carrying only a single abstract method. Is that clear? If you have any questions, please let me know. Otherwise, we'll take a break and then we'll come back. If you have any questions, please do let me know. Any questions?
Sir, one question. Sir, in anonymous class, like it is by default the variables declared inside is final in Java 8, right? The same implementation we do in normal interface with implement, right? So it is also a final by default.
Come again. I'm unable to get it. Sorry.
In the previous class, we have seen that in anonymous class, the variable declared as final by default in Java 8. In Java 7,
Java 8, yeah, final. Yes, final default.
It does the same job of comparing the objects in above, which implements with the normal interface, right? So in implements with the normal interface also, it does the same job. Like it is by default the variable declared as final as class apple comparison implements comparator apple.
You're saying here this
Yeah,
one, right?
Yeah, correct.
Instead of the functional, I mean anonymous class, you're saying you want to use this X here and you want to modify them inside this method.
Yes.
So if you notice here, this is explicitly deliberately a class.
Yeah.
Okay. This is a class level reference. You're getting it?
Yes.
This is a class level reference, so there is going to be no problem. Obviously, instance reference can be accessed in any method, right?
Okay.
You can modify it. But here, that's not the case. That's the difference. This is inside a method. This is inside a method. Anonymous class is inside a method. What variable is this? You tell me. What is this variable? This X is what variable?
It is a final variable.
Okay. Forget about final.
Variable.
Yes, please come again.
Class variable.
No. This is local variable. Correct. This is local, right? Any variable which is inside a method is what variable?
Yeah, local variable. We can assign some value to it.
We need to assign. Yeah, that's a rule. Local variable. Yes, of course, it need to be initialized. A default value it won't pick. That's all fine. That's understandable. But this is a local variable. Local variable reference is what is effectively final. So that's why this anonymous class, which is inside a method, and the method's local variable should be final.
Yeah.
You're getting it?
Yes, sir. I got it.
Now you can also think it in this way. Okay, let's put it this way. Inside the class, you have something called int z equals 77. Okay, now you can ask, can you change the z value? Anyways, that z is also a variable inside the anonymous class. I'm just thinking of having z equals 908. Okay, I'm sorry, z equals 908. So now when I'm saying in the references of z equals, this is what? Okay, this is a static reference. Oh, okay, this is, yeah, okay. That's okay. I'll just mark this as static in that case. That's not a problem. Okay, now you can see I'm still able to modify this. Why? Because this is not a local. This is from the class level.
Global.
Yes, yes.
Ah, final logic, that lambda calculus, when I just again think of lambda calculus, the rule is f of x should not be changed because that is coupled with whom? Function. You're getting it? Lambda calculus is coupled with functions. Everything is function. So function level variables, which is a local variable, if you try to modify inside a anonymous class method or a lambda method, it is not permissible because by default Java 8 is considering it as a final.
Yes, sir.
But you can use it. You can use them. You can use the X here, but you cannot modify, is what they are saying. What variable you cannot modify inside the lambda or inside the anonymous class? The local variables cannot be modified. And in the local variables in Java 8, that is from Java 8 onwards, the local variables are effectively final. What is the meaning of effectively final? Default it is final. But prior to Java 8, it is our intention to mark them as what?
Final.
Final. Correct. Is that
Oh.
making things clear?
Yes, sir. Yes.
Yeah.
So I was thinking in this perspective, like sorting perspective, like because I'm not aware of it, so just I want to know.
Yeah, that's fine. That's fine. That's okay. But anyways, this concept is also followed in lambdas, the same principle we follow. And now I don't need to give this as final because by default this is considered to be final when you're trying to modify inside uh, the anonymous class method or lambda. Yeah. Any other question do anyone have? Still, we have to go a long way to understand this. I've just given a first step of informations. Any questions? Okay, I guess we'll take a short break and then we'll come back. Okay, 10 minutes of break. Am I audible? Hello, please confirm.
Yeah, yes, sir.
Thanks. Okay. I have a software update. Just a second. Okay. So, yeah. So the style of creating a functional interface is what I explained so far. So whether you give add functional interface or not, carrying a single abstract method will make the interface eligible for writing a Lambda expression. So now I was about to explain this in detail. So now the question comes, what is Lambda expression, right? I already gave the definition for it. So the definition for Lambda expression is Lambda expressions are nothing but the implementation of the functional interface, interface's abstract method. So for this abstract method, we are providing a definition for the abstract method via the Lambda expression. Either way you can understand. Lambda expressions are nothing but the implementation of the abstract method that is available inside a functional interface. The rule for functional interface is to carry only a single abstract method. Is that clear? So whenever you see a Lambda expression, whenever you see a Lambda expression, keep that in mind that Lambda expression is written, the Lambda expression is written as an implementation for one abstract method in a functional interface. That is a meaning. Do you agree? So without a functional interface template, we cannot think of having a Lambda expressions at all. That is a conclusion. So if you wanted to write a Lambda expression template or syntax, it's mandate to have an functional interface carrying a single abstract method, because that expression is actually for the respective abstract method. That is a rule. Do you have any questions on this? Okay, now we'll keep this aside. We'll go back to that logic. So going to the application, Apple application, we have the compare method, right? So I'll just copy this, the logic I just wanted to copy. Okay, go to the with Lambda, and here we are going to do now in place of summary, what is the interface, functional interface that we are going to use? In place of summary, what is the functional interface that we need to use as per this logic? Comparator, correct? Comparator for what generics? It's for Apple. Comparator equals. Now I'm going to, instead of anonymous class, okay, instead of this, this is what we did in the anonymous class, right? The anonymous class, what we did, we created that comparator, Apple comparator equals new comparator of Apple, and then we wrote the anonymous class implementation block. Okay, this is the block, the anonymous class block. But instead of this structure, the Lambda is going to look slightly different. Okay. So what is the name that we give? We'll use the same Apple comparator. Okay. Apple comparator equals. Now I'm going to write Lambda expression here. Okay. Lambda expression. But how this Lambda expression would look like? Still admitting. So this Lambda expression would look like this. So I'm going to define the abstract method. You need to think this way. I'm going to define the abstract method. provide the definition for abstract method. Definition for the abstract method. Which is the abstract method that I'm going to define? What is the method that I'm going to define for?
Public void coach.
No, that is, yeah, correct. Yeah, you're correct. But that is Subari's interface. But now I'm using comparator interface, right? In comparator, which is a single abstract method.
Compare.
Yeah, correct. Don't get confused. That's only for example I gave this. Okay, forget about this for a while. In comparator, now the lambda syntax, what you're going to see here, okay, the lambda syntax, what you're going to see here is exclusively for comparators. What method? Compare method. There is a meaning, right? So, do I need to have a method like compare here and then give a definition? Not required. So the name is not required. If the name is not required, then the method name is anonymous. That is how it looks like, right? So I call it, in my understanding, for my perspective, I'm going to call this as an anonymous method. But actually the method definition is for compare, that's fine. But I'm considering it as an anonymous method because there is no name. There's no name for the method. Okay, only you have the argument parenthesis. Argument parenthesis is there, that's all. Then provide the definition for this method. How you will provide the definition for this method? By using like this, right? Open and close curly braces, which I'm not going to do. Instead, I need to separate it, the definition and the method parameter parenthesis using this symbol. And if needed, you can go for using the open and close curly braces and then put the semicolon. Okay, no name, right? No name, and then you have the lambda expression signature. So we call that as lambda operator. What is this sign is called as? Lambda operator, or it is called as arrow token. Either way you can call it. This one I'm talking about, this symbol, hyphen and greater than symbol. Okay, this is called as lambda operator, or it can be called as arrow token. It looks like an arrow, right? Arrow symbol. So it's an arrow token. Now what we have to do here is, this is compare method. Why there is an error it is occurring is because it is asking for some return. What is the return value? I'm saying return value is 0. Okay, if I'm just applying it as a return as 0. The method signature that it is acceptable is for apple A1, apple A2. Correct? What is a compare method parameter is to object. To object is the parameter for the compare method. And that's what I'm doing it here. And specifically for apple, because comparator is generic to apple, right? Now return 0. But instead of return 0, what I'm going to do, I'm going to write the logic. If apple A1 get weight is all this, then you do this. Correct. But again, still it doesn't seem to be that much of lines of code is reduced. Okay, but this is going to be the way forward. Instead of anonymous class, we are going to use only this lambda syntax. So now I will split you these things and I'll explain you. Okay. So what is this? This is your method. What we call it as?
Method signature.
Excellent. Very good. Method signature. This is your method signature. This is your lambda arrow token. And this is your method
Logic.
Definition.
Or we call it as definition. Simple. That's all. Only 3 components for a lambda expression. 3 components. You should remember. 3 components are method signature, but no name for the method. Because it is understandable that this method is defined for whom? For that compare method. Correct? So no name for the method. It's not optional. You cannot use a name for the method. That's what is lambda functions are. This is a lambda function now. And method signature carries couple of parameters and the arrow token and then give you a definition. How many lines of definitions we have written now? 1, 2, 3, 4, 5, 6, 6 lines, right? That's the reason, since it is 6 lines, means it is more than what? Greater than 1 line. Greater than 1 line, I'm going for open and close curly braces. Ensure the semicolon is placed as same as like anonymous class termination. How you will terminate the anonymous class block? By using the semicolon, because it's a statement. Same way here, lambda expressions are also statements consideration. So we go for the termination character called semicolon at the end. The reason I'm using open and close curly braces is to embrace the complete definitions, which is greater than of 1 line. If it is a one-liner of statement for lambda, then this open and close curly braces becomes optional. You need not have that open and close curly braces. You can straight away write it a one-line statement and put semicolon at the end. It's still acceptable by the compiler, because the one-liner of statement principle says there is no need for open and close curly braces. You're getting it? So anyways, now there is another question. Here you have given apple A1 and apple A2. Now the question is, now this is what? Apple is what? What is apple is? What apple is? Apple is a fruit, right? But what technically apple is? Yes, of course it's a fruit. But what apple is?
It's a class type. Yeah.
Come again,
type.
sorry. Come again, sorry.
It is a type.
Excellent, very good. It's a data type, correct? It's a data type. Apple is a data type. So in the method signature, what is required? Data type. What is A1? What is A1 and A2 are?
Argument.
Object.
No, object. No, not an object. We'll call it as a reference variable name. Correct. A1 is variable name, A2 is variable name. What type is that A1 and A2 are?
Apple.
Apple type. Like how we say int type, float type, the same way now it is an apple type. So apple is nothing but a data type. But what data type it is? It is a custom data type. Instead of int, char, float, double boolean, short, byte, char, and so on, we have those are primitive types. These are class types, like custom data types. That's all fine. Okay. Now, instead of having this, can't it be recognizable that this is an apple? A1 and A2, can't it be recognized as an apple? Why should I give apple? Anyways, compare carries how many arguments? 2 arguments. That's known. I have given. When apple is explicitly given, it's referred as data type. That's fine. Can't this be automatically recognized by the compiler? This A1 and A2 is apple. Yes, of course it can. That's the power of lambda. So what the lambda says is, while you're going for method signature, it does not mandate to have. It does not mandate to have the data type. See, still it works. How come is that still it is working? It's because it is understandable that the compare method takes 2 arguments, and the argument is of what type? The apple type. It's already referred in the generic, so it's understandable. This concept, okay, like eliminating the data type in the method signature will further shorten your line of code, correct? Is this shortening or not? Shortening your line of code. This concept is what is called as type referencing. What is the concept called as? Type referencing. Okay, data type referencing. The type referencing concept is nothing but referring the type of the parameter automatically based on the generic type that you use for the particular method of compare. It's understandable that it should be of type apple only. No other thing is acceptable. So why the developer need to explicitly give this apple? This type referencing concept is introduced in Java 8, or is it introduced in any other version earlier? Can anyone tell me? Is this introduced in Java 8 or is it introduced in any other version?
As per my knowledge, it is introduced in Java 5 in comparator. Generics.
Very good. Okay. Yeah, correct. So, correct. So we use list there, right? List of what we gave now, list of Apple, correct?
Yeah.
List of Apple object equals new array list, but actually it's not specifically on Java 5, but Java 5 is the root for it. In the array list, we use a diamond operator, right?
Yeah.
Java 5 introduced generics. That's correct. But in this diamond operator, we are supposed to use what? Apple. So the syntax have to be used in both the places. To be more precise, we already have here, right? So actually what we have to do is we have to apply Apple here. So that's how the generics types before we used to write it in Java 5. But later version, I guess in 7, there is no need for applying this Apple here because the type of this collection is automatically deducted here, referred. The type of this generic is automatically referred here. So the concept of type referencing is coming from here, not in Java 8. But Java 8 is adopting this type referencing concept effectively in your Lambda syntaxes. So diamond operator can be empty. You can place this diamond operator empty. You need not affix them with Apple type. So that's what is happening here. I don't need to provide the type, but nothing harm in providing type. When I provided type, it was accepting, right? Still it is accepting. But you need not, is what they are saying. The same way here, it's optional. Whether you give Apple here or not, it becomes optional. So that concept is what we call it as type referencing concept. Now, these things I used to ask as a question in the interview. Type referencing. What do you mean by type referencing in Java 8 Lambda expressions? I asked them. People who are aware of it can quickly give the answer, but others used to think that, oh my God, this seems to be a new concept. No, it's not new. It's coming from the earlier version itself. Type referencing, type reference concept. Is it making sense? Obviously, we can shorten the code. Right? Like how we have a lengthy URL, you can shorten the URL, right? We have the option for shortening the URL, the application URL or anything. The same way here, shortening the code. That's all. Type referencing is helping us. If you want further clarity, please let me know. Can I add one more parameter?
No, sir.
Why?
It is not defined in the anonymous class, right?
Correct. It's not given in the compare method, the interface. The interface compare. If you look at the source code of this, the compare method only takes how many parameter?
2 parameter, and it will compare the equality.
And that too, the 2 parameters are of what type? Generic type. That's why they are using T there. Okay, we can also, this is already there, right? So like this, we can create our own custom functional interfaces also. Our own custom functional interfaces also we can create as per a logic, as per the use case or as per the project requirement. We can create our own functional interfaces, and those functional interfaces can carry a single abstract method like this. If you want to make it to be more dynamic, then you have to use this. But luckily in Java 8, mostly 90% we need not create a custom interface, custom functional interface, because equivalently for all those logic, there is a set of generic functional interfaces are already there. Generic functional interfaces are already created and kept. We'll discuss about that shortly. Okay. So the generic functional interfaces are already created and kept. And those are called as like predicate, function, consumer, by function, by predicate, okay, supplier. Those are all what interfaces? Functional interfaces. I guess there are 43 functional interfaces are there, which is exclusively created only in the version of Java 8, and those functional interfaces can be used for any generic purpose. 43 functional interfaces we have exclusively. Java.util.functions package. Okay, inside that we are having 43 functional interfaces divided into multiple families. The families are predicate, consumer, supplier, function. Okay, we'll discuss that. Not an issue. I'm just saying. Okay, we can create custom functional interfaces, or we can make use of generic functional interfaces which is already there, or even the functional interfaces which is already inbuilt in some earlier versions interfaces like comparator, runnable. There is also the single abstract method. Those interfaces are also considered to be an functional interfaces. If you notice that they are introducing this term called at functional interfaces added. But when this comparator was invented, when this interface comparator got invented?
In Java 5.
No. Look at this.
Oh,
Java 1.2. Okay. This comparator is there for ages. In Java's second version, 1.2 version itself, they brought this concept. Pretty old concept. But recently in Java 8, they have upgraded this comparator to what? To functional interface. So meaning is what you can write for this comparator? What you can write for this comparator? You can write lambda, or you can call it as you can write lambda expression for this. Why? Because this interface is marked as what? Functional interface, considering this interface is going to have a single abstract method, and that is nothing but compare, and that is what we have did so far. Okay. In different possibility of ways I try to explain this, but still if you have a question, still you can throw it so that I'll try to make it clear, because fundamental should be in place. Otherwise, it's very critical to have the motivation to move forward. The same way if you go to Runnable, when it got introduced?
Yeah, Java 1.
Very first release itself, they introduced this Runnable. But recently in Java 8, they've added this, upgraded this Runnable to functional interface. Now what we can write for this Runnable? We can write
Lambda
expressions. Write lambda expressions directly, not for Runnable. Lambda expressions are applicable for Runnable because lambda expressions can be directly written for run. Yeah. Shall we see how to do that? We already wrote one, right? Or one more example in the Runnable examples. How we can replace this? This code can be replaced like this, right? Runnable R1 equals run method signature. It doesn't take any input. Just you give the arrow token. And how many lines of code we have written in run method here? How many lines of code? Inside the run method, there's only one line of code, right? So I'm just dropping that one line of code here, and we'll just say, okay. Now I'm going to pass R1 and then run this. Why no open close curly braces I used? I didn't use open and close curly braces here. Why?
There is no logic.
Single lines.
Because there's only one liner of statement. No multi-line, right? But nothing harm in giving open and close curly braces, but still you can. So 1, 2, 3, 4, 5, 6 lines of code got reduced to how many lines of code? Only one line of code. Which one would you prefer now? Obviously, we will prefer this one liner of statement because it reduces the headache of the developer. You got it? But nothing harm in placing open and close curly braces. Still, you can have them. Absolutely fine. No problem at all. Okay. Any questions?
Sir, as you told, so this can be implemented with 43. This
43 functional generic functional interfaces.
Yes, correct. So you have shown one file, right, sir? So which is provided by Java, like so whichever method is defined, we can use for that alone, right? For example, like for run we use and comparator. So whichever is defined in the Java provided as a function interface, only we can implement Lambda, correct?
Correct. Only the interface which is our functional are alone applicable for writing Lambda. Correct.
The implementations are already written by Java in the JDK provided by them, correct?
Come again.
No, see this runnable interface. So everything is written in the file which you have shown, right? The implementations are which are already written by Java itself. So we can use Lambda expressions for that only. 43 alone.
43 functional interfaces. No. 43 functional interfaces. So you mean to say this runnable and comparator is also a part of this 43 functional interface, is what your understanding is?
Yes, correct.
No, wrong. No, wrong. See, 43 special functional interfaces, which is available only in Java 8, only from Java 8. This 43 will not count this runnable and comparator. Please ensure that. That's why I explained comparator and runnable is coming from ages. But at the time, it was just called as a single abstract method, not as a functional interface. But in Java 8, they have converted the existing runnable and comparator also to functional interface.
Okay. So in that case, we can implement many concepts like this with use of Lambda.
Correct. Many functional interfaces we can come up. Right now it is 43, but probably there are many places, not only this, there are many places. You also, okay, I'll also show you this one. If you look at this one, okay. We have something called callable and concurrent. Okay. So if you look at the callable is what again? Callable is also an functional interface, correct?
Yes.
But callable is existing from which version?
1.5.
1.5. How many method is there in that callable interface? Only one method.
One method.
In Java 8, the existing callable was converted to functional interface.
Yes. Okay.
But this callable will not be counted for this 43.
Okay, got it.
Okay. So there are, one second. There are some set of interfaces. Which is already existing in the previous versions have been converted to functional interface because those interfaces was carrying how many methods?
Only one method, one abstract method.
Correct. So those existing interfaces are eligible for functional interface. But now newly created, fresh, very new, very fresh interfaces, 43 general purpose or generic purpose or general purpose interfaces have been introduced only from the version of Java 8.
Okay.
So in order to give you more clarity, I thought of taking it later, but anyways, I'll just give you some glimpse on it. Predicate. Okay, if you go to the predicate is a functional interface. Correct?
Yes.
Predicate is a functional interface, but this interface is introduced only from which version?
Java 1.8.
So this predicate is a part of that 43
interface, which is especially provided for Java 8.
Correct. So, and if you notice the single abstract method that is there in this predicate is test.
Yeah, yes.
What is the return of this? Boolean. That's why the name is kept as what?
Predicate.
Prediction. Prediction means what? True or false?
False.
Yeah. So the operation is generic. This test can be used in any scenario, right?
Yeah.
In any scenario where you want the return to be of type?
Boolean.
Then you can quickly think of having whom?
Prediction.
Predicate. Yeah. Prediction. The predicate. Okay. So it accepts anything. It accepts anything because it's generic, right? Input is anything, but output is always what? The return is what always?
Either true or false.
True or false. Excellent. Yes. So in that use case or in that scenario, you can quickly think of having this predicate interface for writing your Lambda expressions. So these things we will in the real time we'll be applying it when we come for streams. Streams is the one place where we can actually leverage the power of Lambda. Okay. Streams is a bit bigger concept, so that's why I've moved it to next week. So next week fully we'll be discussing on streams. Is that making sense?
Yes, sir. Got it, sir. So once.
Yeah.
Sir, sorry, sir. Sir,
Yeah.
sir, I get it, sir. So, is my understanding like whatever methods having a single abstract class, they correlated and kept it on Java 8 to use the functional to use the implementation of Lambda. So,
Correct.
whichever is not implemented, they have written 43 interfaces.
43 additional functional interfaces have been newly introduced.
Single abstract method to use it off with new features.
Correct. That's used for general purpose. Yes. General purpose.
Yes.
If you think of Runnable, okay, if you think of Runnable can be used in where? Only for?
Whenever we implement the threads.
Correct. But these interfaces, these 43 interfaces are for general purpose. Yeah.
This is used for any writing JUnit test cases.
Yeah, anywhere. Yes, anywhere you can think of using, you can use it. Yes.
Okay.
We'll discuss more in detail of that as well.
Okay.
Anyways. Yeah. Okay. So do anyone have any other question? So Java 8 features seems to be less, but actually the logic and the understanding and the concept is more actually. Okay. So try to dwell more in detail and try to do a little bit of practice. Anyways, we are there on the groups. I'll try to come up with some sort of practice work. I'll share you those as well. But ideally, we have to do a lot of practice. But understanding the concept is very important because when you go for interview, okay, Lambda expressions, reduce the lines of code. Don't just reveal that information. Be more expanded with your information. Why Lambda comes in? Okay. What is the main advantage of Lambdas, which are all to be considered as Lambda expressions? So what is the predefined, what is the existing interface which is converted to function interface? So like which you need to brief your answers with more inputs. Okay. So that it says that you have more knowledge on that, right? Okay. Okay, we still have a few more time, so I guess you understood the concept of that type inference, right? Type referencing. Okay, actually, to be more precise, referencing is where is it? Where is that? Here. Okay, we can even call it as actually here it is a type inference. Okay, I just pronounced it as referencing, but that's okay. It means the same. To be more technically detailed, you call it as type inference. Inferring. Okay, infer means judging. Infer means judging the type. What is the type that it is judging here? Apple. Correct? Yeah. So this concept is called as type inference. Is this clear? Okay. So import java.util.function. Can you see there's a package called function? This is a new package introduced in Java 8 as a sub package in the existing package called util. You already know, right? Util is already there. We use for collections. In that collection API package, they added one more package name, sub package called function. And in that function, you can see all the list of interfaces. Can you see here? This is what I said. Countability will come to 43 approximately. Exactly. 43 functional interfaces. Or if you count it, it will be 43. You can check if you have your ID, you can just check it, count it and see. Okay, 43 functional interfaces are there. But they are grouped into certain categories. What are those categories? As I already briefed you. 1, the predicate. 2,
Consumer.
consumer. 3, the supplier. 4, the function itself. Okay. Now predicate, just now we saw the predicate. Input anything, okay? Input anything, but return Boolean, correct? Is this definition correct for predicate? Input anything, but return only Boolean. How many parameters are given as an input? Input is how many parameter there? 1 parameter. Just now we saw that, right? Predicate.
Yes, sir.
If you see here, the predicate has a method called test. The test takes how many parameter?
One parameter. T.
1 parameter. What type of parameter is that? Any type. But it should return what always? The Boolean. Correct? That's what I'm saying. Input is anything, means any type, but it should be 1 parameter, any type, but should return always Boolean. Correct? That's what is predicate is. Consumer. As the name suggests, consuming. Consume means you accept. Consume, accept. Accept means, okay, input is anything, 1 parameter again. Every time I'm suggesting that it is 1 parameter. Okay, is anything, input is anything, but return is, what is the return? Return is void. Okay, shall we see that? How the consumer looks like. So if you go to this consumer, let's understand the basics and then later we'll see the usage of this. Okay. Consumer is a function interface introduced in 1.8. What is the method name? Single abstract method name. Accept. How many parameter it is accepting?
1.
1 of what type? Any type. What is the return?
Void.
Void. Because it only consumes. It only consumes, but it never emits. It never emits it out. Okay. It never returns anything. It just consumes it and keeps it and you does something with whatever you pass in. Okay. So that's what the consumer is all about. So consumer is just about consuming anything, but never emit it out. So that to 1 parameter. Okay. So you understood when to use. So there might be different use cases where you will accept things, but you don't need to return anything. At that time, you can think of having consumer. Supply. Supply, as the name suggests, supply. Supply means give away. Correct? You give it. You give it. Supplying, give it. So you will get it. You will get it. Okay. So if you look at the supplier is like opposite of consumer, correct?
Yeah.
If you look at the supplier, you only get it. Get. Supplier is a function interface of version 1.8. What is the method name? Get. What is the input? No input, but what is the return? Return is anything. Return is anything. So how do you define? 0 input. 0 input, but return anything. Why? Because it's supplying. It's supplying it to you. Supply, return it, supply. Give away, give it. Predicate is analyzing it, true or false, return true or false. You accept something, you validate it and return true or false. Consumer, you accept one parameter, but do anything with that, never return alone. You print it, you do whatever you want, you do it, but don't return it. Supplier, nothing is accepted, but he is ready to give out, or he is ready to give away, or he is ready to give things as a return. So zero input, but return is anything. It can be anything from the return. Function, the last category is function. What function is? Function is both of consumer and supplier. Okay, function is both of consumer and the supplier. So you have two things. One is the input, another one is the return. Okay, and the method name is apply. Can you see that? What is the method name for this function? Functional interface. Function functional interface. Function functional interface. It is called as. Return is anything. Return is anything. And input is anything. But how many input? Only one input.
One input.
So you accept anything, you do something with that anything, and then you return anything. Accept anything, you do something with that anything, and you return anything. So you input is also there and return is also there. That is what is your function. So function is a combination of consumer and supplier. Perfect. That's all. And you think of in which use case you can make use of this. Ideally, you can use that logic. So apply, right? Input one parameter, right? Anything, and return anything. Correct? In predicate, what is a method? Test. Test method. Test method, accept method, get method, apply method. Correct? And these are all what interfaces? These are all what interfaces? Functional interface. And these are ready-made. Ready-made functional interfaces kept inside the java.util.function package. And these are called as what functional interfaces? General purpose functional interfaces introduced only in Java 8. Or in not introduced in only in, it is only from, available only from Java 8. Is a theoretically the concept is clear or not?
Yes, sir.
But how do we use it? When to use function? When to use supplier? When to use? Now you can also question. You said there are 43, but there's only 4 things that you have shown. If you see that there will be a by thing will be there. Okay, by consumer, by supplier. I'm sorry. Yeah, the by function. So when you see that by term, okay, by consumer, by function, by operator, by predicate, and so on. What technically happens is there is no by supplier. Okay, I'll tell you why there is no by. By means what? By means 2. Correct? By means 2. Uni means 1. By means 2. So the answer is there. You can easily understand. So when I say by consumer, it consumes how many parameters?
2 parameters.
2 parameters. When you say by function, it accepts how many parameters? 2 parameters. When I say by predicate, it accepts how many parameters? 2 parameters. But why not for supplier? Why there is no by supplier?
Because there is no limit. It can supply anything.
Supplier is only for return, but not for accepting. Right? So there is no input for it. So there is no by supplier, but by predicate, if you see. So if you see the by predicate, there is a test. Correct? Same as predicate, but how many parameters are there? 2 parameters are there. So you can ask, do we have 3 parameters? Try predicate, try consumer. No, there is no try. Okay, there's only by predicate, consumer, by consumer, function by function. But for supplier, it's just supplier. Then what else we have in that 43? Okay, this counts to somewhere 7. What else you have? You can see that by function, by consumer. Then you have binary operator, okay, Boolean supplier, double binary operator, double. These are all for primitive to wrapper implementations. Okay, in double itself, you can see double consumer, double function, double predicate, double supplier. What does it mean? Before predicate means it will accept what? Predicate will accept what? Anything. But now double predicate will accept what? Double predicate will accept
Double
what?
data
Double
type.
data type.
Correct. Only the double. Okay, it will accept only the double. That is the meaning. See, it accepts only the double value. But before it was generic, right? It accepts anything. So they have made it possibility in, they have made it this general purpose function interfaces in many possibilities. So you have int consumer, int function, int predicate. Okay. Right, int to double conversion, int to double conversion function, int to long function, int unary, long binary, long to int, object int. A lot of further data type specific things are also there. That's why it is counted to 43. But how many families are there? How many families that are there? 4. Predicate, consumer, supplier, function. This is what you need to register and you are ready for your interview. But totally there are 43 functional interfaces are there. Pre-ready-made available from Java 8. You're getting it?
Double supplier is there, sir.
Where is?
Double supplier.
Double supplier is there. Huh? It means the return should be the consideration, right? You go for double supplier. The return is what? Return is double. But the input is always 0. That you cannot change, right? It returns, it supplies only double. That is the meaning, double supplier. But the by supplier was not there because the by supplier consideration is no input. So that by supplier is not required. Can I return 2 things from return type? Return type is only one, right? You can return only one thing, one type. So obviously that by supplier consideration is not there, is what my understanding is, and that's what would have been thought by the developer who, or the developer community who thought of bringing this 43 function interface. You might have a different logic. Okay, now let's say, for example, you have asked a right question. Can we have a combination of something different, parameters or something different? I want to use it for exclusively for Apple supplier. Can I have it for Apple supplier? That supplier will supply only Apple. What am I supposed to do? That supplier will supply only Apple. What am I supposed to do? What am I supposed to do? Sabri will its own functional interface called interface Apple supplier and test, accept nothing, but return what? Apple. Are you getting it? Now, can it be introduced? Can it be included in 43 interfaces? Can I include this in 43 interfaces and count it as 44?
It is our customized one.
It is a customized fashion, but that's fine, even though customized. But this logic cannot be used beyond Apple, right? Are you getting it? Beyond that domain, okay, beyond that domain, you cannot use it. So you cannot call this as a general purpose functional interface. Yes, of course, it's a custom made. It's a developer customized functional interface. That's fine. It's not a part of 43. But what I'm saying is, if needed, you can create. If needed, you can create a custom functional interfaces according to this logic. But this cannot be a general purpose. It's only for a specific domain you can use. That is a meaning. And you can mark them as at functional interface, or you don't mark them at functional interface. Still, it will be an at functional interface because it is carrying omni method, single abstract method. These things are clear. I guess we have nearing to the time. If you have more questions, we'll discuss. I don't want to take it further with any topics. Probably this week in between either Wednesday or Friday, I will take 1 more hour to bridge the gap. Okay. Uh, since we are going a little slow and little expanded, I don't want to rush it. So probably 8 to 9, there will be a session either Wednesday or Thursday, depending upon my workload. Okay. So yeah. So now it's question time. So if you have any questions, please let me know. Whatever questions we'll discuss.
Sir, one question. In the older version of Java, we write in interface, we write more number of abstract method and we implement it. But
Correct.
here Java 8, we go with only one abstract method. So the implementation wise, so it is reduced, right? In Java 1.8. So we cannot implement we cannot do multiple implementations.
No. See,
what are the advantages of?
No. So see. I wanted to create an interface called, let's say iPlayer. Okay. And I have a method public void t1. This is an abstract method. Okay. And I can have one more public void t2. Public void t3. We are still in Java 8. Okay. This version is Java 14, means it accepts Java 8. Now I go for class ABC implements iPlayer. Correct?
Yes.
Now how many methods you need to override here?
3 methods.
So the rule stays same. Whatever you studied in the earlier Java version is still there. But this is not for functional interface category. This is not applicable for Lambda. This iPlayer is not applicable for Lambda. You cannot think of writing a Lambda syntax for that.
Yeah, we can use in either way. We can use more many abstract class as in a single abstract class based upon our requirement. So Java is not enforcing that you should not use a single abstract method only.
One second. See, don't get confused. It's not abstract class. Please call that as abstract method. We can have more abstract method in interface. Still, even in Java 8, we can have more abstract methods in interface, and we can use it as an ordinary implementation and implement all the abstract methods. But when you need a Lambda syntaxes or Lambda implementations, then only the interface should carry a single abstract method. That's all.
Yes.
Got it? Yeah.
Yeah, I got it, sir. So I just put in my mind that only we can use single abstract method and we can implement Lambda in Java 8. So we cannot go with the older version of.
No. Wrong. We can still go for older version. It's still applicable. Yes. Okay. Now, if you see that you need to just override all the methods here, otherwise it will keep throwing the error. T1, yes. But still there is an error. T2, but still there is an error. So I go for T3. Now there is no more error.
So based upon our requirement, if we see,
when there is a Lambda requirement comes, then you go for a single abstract method concept.
Yeah. In our code, if we see a single abstract method, then we can, instead of writing 4 5 lines of code, we can simply write with Lambda. Exactly. Or else we have to go with traditional approach.
Yeah. If that requirement is not there, then of course you can go for traditional approach. Yes. Yeah. And moreover, if you look at this Java 8, the one more thing that we have to learn here is, that's what in the coming weekday we'll learn. What we are going to learn is the interfaces have started to accept default methods and static methods. That's another concept, right? Yeah. Usually interface in older versions, what will be there? Only abstract method will be there, correct?
Yes.
Only abstract methods, right? But nowadays, from Java 8, starting from Java 8 version onwards, it accepts method with definition. You can write T4 with definition. Okay, and that will be a default. You need to use a keyword called default and mark them. You can have another method called T5 with definition. You can write something inside that itself, and you mark them as static. So static methods and default methods have newly introduced in Java 8. Not only for functional interface. In functional interface, you can use default method and static method. In the normal interface like this, even though if it is not a functional interface, you have more than one abstract method. Okay, so there also you can use default methods and static methods. So this is a bigger discussion. It will take some time to make you people understand, because when we have default method and static method, then the rule stays same like abstract class. In abstract class, what you will have? In an abstract class, what you will have? You will have both abstract
methods
method
and
and non-abstract method, correct?
non-abstract. Yeah.
Then it seems the interface also seems to be like that. You can have abstract method and you can have a non-abstract method, which is like default method and static method. It looks more same. Abstract class and interface looks more same. No, not like that. There is a big difference. There is a purpose for interface and there is a purpose for abstract class that we will discuss more in detail on the coming week.
Okay.
This is also a very important question that will be asked in the exam. I'm sorry, in the interview. They will ask this. I tend to ask this. There is a people say quickly interfaces Java 8 it accepts default method and static method. But the only question that I'll ask them is, okay, good. It has default method and static method. Very good. Now then, what is the big difference between an abstract class and interface? Because you cannot create an instance for abstract class, correct? No instance for abstract class and no instance for
Interface.
interface. Then what is the big difference? When you bring before it was very clear, abstract interfaces are purely abstract, correct? But abstract classes are partially abstract. Why partially abstract? Because it has both abstract method and concrete method.
Yes.
Concrete method. That means it's a non-abstract method. Concrete methods are non-abstract methods. So it is partial. But interfaces are purely abstract. But from Java 8 onwards, when it started to accept a default method which is with the definition, then we cannot call it as purely. What is the big difference between an interface and abstract class? I used to ask this question and the people used to get locked. But still there are people who still give answers for that. Okay, that's what which we will learn on the Wednesday or Thursday. I'll be posting it on the WhatsApp group, the link a day before or so that we'll join there and learn more. So any other question? Any other understandable things that you want to get clarified with? Please let me know.
So one thing is like the Lambda implementation seems like similar to the callback arrow function that we have in JavaScript. Like I think you have mentioned that.
Yeah. Yes. Yeah. So
Also,
it's not like callback here, but this is it's like we can simulate it, but there it is deliberately a callback which doesn't carry any method. It doesn't follow any interface principle, right? JavaScript doesn't follow any interface, right?
Yeah, right.
Just like that, you can bring that syntax in Java.
Okay.
I'm sorry, in TypeScript. Okay, just like that, you can put the syntax. It will work.
Yeah, right.
Now what I can do is I can just call this in TypeScript. What I will do is I'll just say let's say I'll just declare a variable like sum. That's all I'll do. So when I'm calling this method, how I will call this is sum of.
Sum.
Yeah. So now what happens is, but in TypeScript, this is not following the rule of interface, right? Just like that, abruptly you can write some anonymous method implementations in TypeScript. But this is more standardized. You have to go and come via the channel of functional interface. Then only you are entitled to write the arrow token syntax. Otherwise, just like that, in any callback event implementations, you cannot use them. It won't accept.
Yeah, right, sir. The out of scope question, another thing, is that something related to AWS Lambda and this one?
No. Okay. AWS Lambda is entire. Yeah, AWS Lambda is we'll call it as FAAS. Okay, AWS Lambda is FAS. So what is FAS?
Okay.
Function as a service. You can relate it. Of course, you can relate it. Function as a service. So you technically write a function there. Okay, but that function can be written in Python or it can be written in Java. Since it's since the name is more relevant to that Lambda, but the functionality is different. Okay. Lambda means it's function. First class citizen is function. So But in AWS, it's function as a service. That function as a service is a call which executes for 20 minutes. Okay. Maximum duration a method can be executed is for 20 minutes. And that's majorly used when you're want to invoke that function in terms of background process.
Okay, sir.
Yeah, that is a different story. Yeah. But of course, you can relate that Lambda equivalent to a function only because we write function there. Yes, of course. But it is called as a function as a service. But this concept is not like interface or something like, because you can write it in any language. You can write it in Python, you can write it in Java, you can write it in C#, any language you can use. Yeah, any other question? Okay. If you have any further questions, you can just throw it up on the group. I'll try to respond at the best at my possibilities. I'll try to share code. Anyways, the recording sessions will take some time to upload, and as usual, like how I did in the earlier Spring Core training, the same way I'll share the accessibility to the things. Once after everything is set up, then the download options will also be activated. So if there's no further questions, we can close the call today. Sorry, close the session today.
Sir, excluding that 43 general purpose generic functional interface, all the remaining SAM interfaces are converted into functional interfaces, sir.
Come again? I'm not getting general in functional interface. Okay.
So as we discussed, 43 are introduced in Java 8.
Correct.
Excluding this, we have some existing functional interface, existing interfaces which are converted into functional interface in Java 8.
Correct. Correct.
So all the single abstract method interfaces are converted into functional interface. Sir. Just curious to know.
Correct. So 43, let's say 43 plus existing is, let's say, I don't know how many. Okay. But for example, let's say 20. In the throughout Java API, let's assume that 20 interfaces, okay, which is existing interface coming from 1, 2, 3, 4 in different versions. All those 20 are converted to functional interface because all those interfaces are carrying how many methods? Single abstract method, right? So 43 plus 20, now totally how many?
63.
63. That's right. But I don't say it is 20. It's only for example I'm saying.
Okay.
Yeah. See, you can also take it this way. Okay, Java 8, this is something. Let's go to Spring. Okay, in Spring MVC, okay, in Spring MVC, if you would have recalled, okay, at enable MVC is what we do there, right? We write a class, and then I said you can do some implementations of one interface there. If you would have recalled, that interface is actually what? It's a functional interface. In terms like in any class, when I was saying, the Spring MVC certain interfaces are converted to functional interface because those interfaces are having how many method? Single abstract method. After the introduction of Lambda Java 8, even the Spring framework got upgraded to their interfaces which are carrying single method as a functional interfaces. So you'll be eligible to write a Lambda for that as well. So every library, since the impact is in the core language Java, every other libraries like Spring, Hibernate, everyone started to follow the Lambda. Wherever their API is having a single abstract method interfaces, existing interfaces are also eligible for functional interfaces. Are you getting it?
Yes, sir. Got it.
It's not restricted only for Java 8. Java 8. Java 8 is the core library. Core language. It starts from there, but all other dependent libraries have also upgraded. That's why they will say sometimes it's not compatible because Spring this version supports Java 8. So your older version of code will not support something like that. That's because they've upgraded. They've upgraded to the supportive of Java 8. Any other questions? Yeah. Do anyone have any other questions? No questions?
No questions.
Okay, fine. Yeah. Thank you so much. Thank you so much for your time. 3 hours is pretty long. I knew that. So we'll catch up in the weekday for 1 hour, 8 to 9. Probably, I don't know which day it would be, but be prepared. I'll throw the invite much earlier. And then we'll again connect on Saturday to have more learning on streams. Streams are pretty big, but prior to that streams, we have many more things to be covered. Small things are there which we have to go in detail, including the existing functional interfaces, the the 43 function interfaces, some idea of usages. Not all the 43, but at least those families we will see. So thank you so much. Have a great day and have a great weekend, and we'll connect up in the weekday. Thank you. Bye.
Thank
Thanks,
you.
sir.
Thank you,
Bye.
sir.
Thank you.
Thank you. Bye.
Thank you.
Thank you. Thank you.
Sir,
Yeah.
sorry, sir. I think I couldn't able to come in the weekday. I'm going to the company directly and I'm working. So I will make sure to watch the recording session before coming in the Saturday.